Can we see the numbers?
And so it should be live now. All right.
Okay,
Cool.
cool.
Well, what do we have in store this
Yeah.
week?
Hello, everyone. Welcome back to our weekly live stream. My name is Kevin Hyas. I am a production lead intern here at 3DQ. I've got some experience working in an engineering print lab and some other hobby stuff. I'm joined again with Matteo Pekic, the co-founder and chief of innovation at 3DQ. Would you like to tell a little bit about yourself?
Yeah, well, I mean, if you guys know this story, I started 3D printing over 5 years ago now. Of course, as a hobby, but eventually started taking on orders and doing a bit more professional stuff, and quickly realized or quickly started developing this automation technology, which is the foundation of 3DQ today. So we've been running this tech in-house on our 36 production machines.
Autonomous machines.
Yeah, and now we're going to talk to you guys about
how you can turn your at-home or your lab or your print farm printers into an autonomous production machine.
Yeah.
So we're going to talk about how to turn your machine into a high volume printer, why continuous printing is important for that, how we do that through our stick and release with our vapor print beds, a bit about how the software works and how kind of the files chain, and then how to get your own kit. So if you were with us last week, we talked a little bit about this magic pizza box that looks very appealing.
Yeah.
So we're actually going to show you a bit about what's inside.
So we launched this kit yesterday at 11:30, and already 80% of the early birds are sold for the discounted rate. So if you want to get in on that, there's still 6 left, I believe. And given how fast they sold out, we decided to do a second early bird round, so you can check the website for details, and we'll talk about that at the end as well.
Yeah, so we're just going to go through what's involved or what's included in the kit. It's not too much. Like, the kit's fairly small. So you start off with a QR code that will be your personalized software key.
Yeah.
And that'll be dependent on whether you got the early bird or just a pre-sale.
Okay, and so the kit is kind of comprised of 3 main components. The first one is the tilt frame. So that's just a couple of aluminum extrusion and some 3D printed brackets.
You've got some panels here, which are part of what we call the part guidance system. So the printer, as you would have seen earlier, is tilted at 30 degrees, and that's to help the prints kind of slide off once they're pushed off of the bed. And in our testing, we noticed that they can get stuck. There's a lot of different prints that might
a lot of
be
different shapes you have to account for.
Yeah, so that's just to make sure you don't get a jam that destroys your printer.
Yeah.
We have some relocation hardware 3D printed for the spool holder and LCD screen.
We also have all the hardware used to put this all together included.
And last but not least, probably the most important thing, we have our Vapor. What does Vapor stand for?
The acronym is a lot cooler, but it's the Variable Adhesion and Automated Part Release Print Bed. So this is a print bed that we've specially formulated to provide high adhesion at printing temperature and release parts when it cools down. I noticed over there's also a bit of a filament sample.
Yeah, a little bit of a special something here. Well, we'll talk a little bit more later about what this is for. But for now, why don't we continue on with the printer. So these are all the parts. We've got a stock Ender, mostly stock Ender 3. We do have a couple modifications, such as the inductive probe and a few things that you can't really see, such as the firmware. And what do you need on your ender before to get this kit going?
So the kit will work with a completely stock Ender 3 if that's what you have,
Hmm.
but we found, and we have a couple recommended upgrades, which we found extremely useful on our production system. So in our case, it's got the inductive auto leveling probe,
Hmm.
and it's also got a V6 hot end, which we just
Yeah,
found to be more
so these are
consistent.
the mods that we've had on our production printers. If you saw a little bit about our 1,000 hours in 5 day achievement, these are the mods that ran that successfully. So that's what we recommend. Of course, like you're free to do what you want. There's thousands of mods out there, and we've done our best to make it compatible with everything.
So maybe as you get into taking off the LCD
Hmm.
and the spool holder, I'd like to pose a question to chat, which is if you didn't have to attend or babysit your printer, like, what would you do with all that free time? What would you want? Have you ever had a project where you had to print a lot of a single part? Um, because that's really kind of the two main benefits of having an automated 3D printer. One is the high volumes you can get. 3D printing is slow, but when you factor in that how much time is lost to just waiting for waiting for an operator to come and clear the part, if you could run your printer 24/7 and have it auto clear, um, your throughput goes up massively. So we did do a recent test, which we talked about in the last stream, where in order to get 1,000 hours of printing, our our production specialist Kieran only had to spend 3 hours of his time. Half of those 3 hours were spent changing filament, and the other half were spent doing like small maintenance type tasks. So
Hmm.
there's definitely, in terms of throughput, in terms of what you'll be able to push through your printer, um, having automation makes a massive difference. Um, so actually, you might notice in the corner down here, we have a stream of one of our kits, which is going to be up 24/7. We'll host it on this channel, but if you ever want to check in and see what the printer is doing, that stream will always be up. And you can see, oh, it actually looks like somebody cleared the parts out, but it's been printing headbands for the last, I think, 18 hours
Yep,
now.
yep,
Um, so you've got the LCD off.
yep.
We're going to start with the trickiest part of the assembly. Is
Yeah.
that right?
Hardest part, it's not terribly difficult, but it does require care. What we're going to do is apply the vapor print bed. So this bed comes pre-applied with adhesive with a paper film on the back, and this is directly adhered to the aluminum build plate. And Matteo, why do we choose to adhere directly to the build plate opposed to say using like clips?
Sure. So, kind of while we go into that, I'm going to set the
Hmm.
build plate at 40 degrees C just so the for the adhesive. But the reason we have to adhere it is because um, in order to get consistently looping prints, you need to have a consistent print surface.
Hmm.
Most print beds are sort of designed with the assumption that there's going to be a print operator at the beginning and at the end of each print.
Yeah.
And then that print operator would be kind of inspecting the bed between prints, applying new adhesive if it was required, or like going to the bed, flexing the build plate, and even re-leveling the bed between prints. So like with removable build plates, you actually introduce a lot of variability in that, like, because they're only clipped on and not fully adhered, heat cycling will cause them to shift
Hmm.
over time, and that can become a major problem when you're looping unattended, because your if your base isn't consistent, then the rest of your print won't align to
Yeah.
that.
And with that in mind, what I'm doing right now is just wiping the build plate off with just standard rubbing alcohol. And when you're changing your build plate, there's a chance of dust. Just now I noticed there's a few filament specks,
Yeah,
and that just comes from when you're changing uh,
like
different.
really working with your
Yeah.
printer. Like
Or
printers
there
generate a
could
lot
there
of
could
dust.
there could be some hair or whatever. And again,
Yeah,
you
I'll
want a
tie it
consistent
back.
build plate. So we got a question. Can I put a flex steel plate? Uh,
Wham bam, super flat. So flex steel plates tend to use like magnets to keep themselves flat. It is possible, but we've actually done experiments with magnetic backed versions of these plates, and the for magnetic backed plates, they will tend to shift over time. A spring steel plate can be kept super flat with the correct hardware. So if you wanted to put this on a steel plate, you could try it. We don't officially support it, like, because even then now you have two different substrates which will flex at different levels of temperature. So if you do want to switch over, like in the case you're prototyping some strange
weird material. So yeah, we do have like the two standard materials are just PLA and ABS.
Yeah.
We're still doing testing with other things. You shouldn't need to change your bed at all unless you're doing something like that, in which case we have tested, and you can put a bed such as a glass bed on top.
Yeah, if you want to switch back to your old bed at any point, we would just recommend sticking it right on top. It doesn't make that much of a difference in terms of heat up and cool down time.
Yeah, a little bit, a few extra minutes. I recommend putting like a bit of electrical tape in between, just so you don't scratch your surface.
Yeah.
Anyway, so I'm going to continue on.
Hopefully that answers your question. Yeah, because the magnet hold can be really strong, but through our testing, we found the adhesive is the best way.
So I'm going to talk a bit about the adhesive. So when you get your vapor bed, you might notice that the adhesive doesn't quite go all the way to the edges. A little hard to see on the camera, but what I'm going to do is just mark two corners of the adhesive.
So on the adhesive side, that's where you're marking it?
No, I'm using a dry erase pen on the top.
Okay.
So that it'll rub off after. And I'm just marking the very edge of the adhesive on the board on two of the corners.
Because once he peels off that backing, the adhesive is almost completely transparent. So
Yeah.
adding those marks really helps with the alignment.
So bed's at 40 degrees.
Yeah.
I'm going to tilt it my way. You want to avoid touching the center of the bed, but it's all right if you do it because it's easy to clean off. It's just over time, lots of touching can degrade the coating.
Yeah, if you have your fingers oiled on the print surface, it can prevent proper adhesion.
All right, so
Okay.
there it is. You get, like I said, you can't really see it.
So this is the most careful step. He's going to line those two marks against the back.
Getting my tie in the way.
Yeah, your safety tie. Okay, perfect.
Okay, so let's line up. And what I'm going to do now is flex the bed a bit, so there's a bit of a curve. And I'm going to use a microfiber cloth.
Just
and
push down.
Yeah, so start at the middle and kind of push towards the corners while decreasing the flex. And the reason you do it like this is to eliminate the air bubbles underneath, because once again, air bubbles cause an uneven surface, and an uneven surface means inconsistent prints. So that should be good.
There's a question in chat, is the bed PEI? No, the bed is a custom formulation that we've been developing over the last couple of years that's specifically designed for high adhesion during print and then auto release. So while you can get similar effects sometimes with glass plates or PEI sheets, it can be very dependent on the shape of your part. And so this bed is specifically formulated such that it's much less dependent on, like, the adhesion is so high when it's hot that you don't have to worry about that. And then the release itself is quite consistent whether you have a massive contact area, like we've done vases that cover the entire print surface.
Some pretty complex pieces.
Yeah.
So just with that in mind, we want to ask you guys, so just a reminder, if you want to comment, you can just make a Twitch account quickly. What's the worst experience you've had with stick and release on a printer, whether it's an Ender 3 or something else, whether it's first layer adhesion, something big and you come back, it's got a warping, or, just can't get something off. Matteo, do you have any experience with that? With something terrible?
Yeah. In fact, I have a couple experiences with, like, I have one which is like a nightmare using adhesives, which comes from back when I first started 3D printing. The main community was still on the RepRap IRC. There tended to be like a lot of debates going on, and I happened to join
Well, specifically like PLA versus ABS.
yeah, that was the kind of the big discussion at the time when I joined. And I guess being a victim of circumstance, I happened to join when the ABS fanboys were in full swing. So I'd actually started, my first prints were done in ABS, and I had this Roadstock Max, which has a really massive build area, and then that can like that was just a nightmare for ABS print. So I eventually had to resort to doing ABS slurry as my adhesive.
What's an ABS slurry?
It's you take acetone, like nail polish remover, and you dissolve some of your ABS filament in there, and then you use that solution, you spread it on the print bed, you turn up the temperature,
Sure.
allow all the like acetone to evaporate.
That sounds great for your lungs.
Yeah, it was. Yeah, I couldn't enter my bedroom at the
You
time.
did this in your bedroom.
Yeah, yeah.
My dad's
Like-
rolling over in his couch at home.
Yeah, like definitely I lost a few years of my life to that IRC. But so what would end up happening is you'd have to reapply this ABS slurry every single time I was doing a print. And so like you would put it on, and then you'd have to make sure once the print came off to scratch it off as well, and it just made an enormous mess and like stained the inside of my printer, and you get these like when you scraped it off you get these flakes, and it just made a huge hassle between prints. So again, that's sort of like the low rumblings that sort of pushed me towards developing this automated print surface kit.
Yeah. So just with that, to set the adhesive, I've turned the temperature up to 90 degrees, and it's almost there. After it's 90, we'll let it cool down.
Yeah.
And then now I'm kind of just putting the tilt frame together. So it's pretty straightforward. Just got some drop-in T-nuts. And we'll continue once we're done this.
Sure.
I got a kind of an opposite story to
Yeah.
that. That's kind of like a first layer adhesion, trying to get that first layer to stick. I've got a story involving kind of getting a print off the bed. So a lot of different print beds, such as kind of glass or like specialty glass,
Like
use
borosilicate.
they overcompensate by making a super adhesive
Oh, like
build
the
plate.
ceramic coating
Yeah, like a
type?
ceramic coating on like the Ender glass bed. And in a previous position, I was doing research at a hospital. We were doing aerosol tests for the efficacy of different masks, so to kind of make this experiment more realistic, one of my projects was to make this breathing simulator. And this used a linear actuator to push down a lever that squished and released a resuscitation bag. So there's just a little rubber bag that would inflate and deflate as you
Like a
squished
whoopee
it.
cushion.
Yeah, kind of like a whoopee cushion,
Yeah.
but less fun. So to hold this in place, I made this little 3D printed kind of bracket. Like if you think of a soccer stadium, it's got like a rectangular cutout, and the stands are kind of triangular prisms around, kind of just to support it in place. And so it's a pretty flat print. There weren't any
Could you pass me a
overhangs.
couple screws?
Yeah, sure. They're in the hardware bag.
Perfect.
And because I was working at the hospital and my printer was at home, I'd have to set the prints in the morning before I left. I don't want to have the printers running overnight because then I don't get any sleep. Well, I guess that's up to preference, but I've
That's
got
up to
some
preference.
I know some printers like are a Delta at my lab that sound like trains. So like first time I printed it, I came home and I dug my fingernails under, and like the brim was coming up, but I could not get that first layer up. It was just so stuck on. I put it in the fridge, it still wasn't coming up. And the first time I did, I actually dug my thumb in so hard that I just broke the
Just
infill.
like punch through the side of the
Yeah, I just went like
Yeah.
pulled it in. So I just like take the Z offset up and kind of change the design a little.
I also have a high adhesion story. I found the print yesterday just to show it off, but I this was the first time I purchased an Ender 3. I was trying to push the limits of the detail you could get on it. So I set up this really ornamental skull print, and it was at 0.075 millimeter layer height, which was like I've gone lower since, but it was quite a nice print, but it did extend the print time. It ended up being 18 hours long.
Oh, that's
And
long.
it was long, but like when I came back in the next morning, and keep in mind I was just printing on the default build surface. Um, I came back and I saw this beautiful print on my Ender's build pack, and when I came to remove it, I'll show you what happened. So here's a beautiful 18-hour print, and then the entire first layer actually stayed stuck.
Oh wow, just pulled the brains right
Yeah,
out
it
of
literally pulled the brain, like the first layer and some of the infill actually came out of the skull, and it was very sad, but I also like I just sat down and started laughing just because how comical it was to put it out. So definitely like there a lot of printers and a lot of like adhesives overcompensate.
Yeah, so like don't you wish you would have had this like
Yeah, if I
3Q
had
looping
wow,
kit with
way
you?
to link it back. If I had the kit at the time,
Or even myself, if I
yeah.
had it, like I could just set prints in the morning, come back and have like 3
Yeah, I'd
copies.
have like another skull maybe by the time I've gotten back.
Yeah, we might have to wait a few days.
Yeah, but yeah, there's like all sorts of these issues I was experiencing, and as my volume kind of as I was running like a mini print service, as my volume started ramping up, it would be so annoying to have a beautiful print completely ruined by like something right at the end.
Alright. That's cooling down.
Yeah, I've already shut
Cool.
it.
So we've got our angle brackets here.
Probably give it another minute.
Give it another minute. Yeah,
cool
that's a
down.
good idea.
Yeah, just because we don't want to end up burning our hands when we're installing the.
Yeah, safety is
the
always
frame.
important.
Most of the time.
Most of the time.
Yeah, we all have our fair share of nozzles scarred. It's like holes in our fingers from. Do you ever do the thing where you're replacing a nozzle but you don't want to wait for it to cool, so you like
Oh, you just
try to put it in with your fingers before it gets too hot? Yeah. Hopefully our production engineer doesn't get mad at us for that safety procedure. Okay, so I think we're good to put the frame on.
Yeah, so let's just take the LCD screen off there.
Okay, just gonna shut this down. All right, so the frame, the print looping kit frame, again, it's designed in a very simple way, and part of that being like to keep costs down, but the other part is so it's very easy to modify. So it uses the standard 2020 extrusion. We're already like considering doing mods like moving the power supply underneath and mounting it to the base rather than the side, because that we found like a lot of people do that because it helps relieve strain off the printer, and pretty much any sort of inconsistencies that a printer might have get extremely magnified if you start running it 5 or 10 times the amount you had been running it before. There's a question, how does TPU do on the bed? Right now, we've had mixed success with TPU. TPU is like extremely sticky almost no matter what bed you print it on. So we've had I would proceed with caution if using TPU. We don't officially support it just yet, but we're working on a couple ideas in the background for how we could get TPU to loop properly. There's another question. How long does the printer have to wait to cool down? Actually, you did some testing.
Yeah.
On this,
So here, do you want to do that?
let me take care of this part.
Yeah, so you're just gonna put the printer on its side like when you first assemble your printer for this part. Anyway, with the cooling, we did some testing, and it does depend a bit on the ambient temperature that you're printing in. Colder climates are generally better because, like we mentioned, this print varies adhesion.
Part of the variable adhesion is the ambient temperature.
Yeah, it's at the different temperatures.
So yeah, like one mod that you had looked at was installing a fan to push air, and you found like
Yeah,
massive increase.
just on average, it would be about in our production, it adds about 20 minutes, like a couple minutes for heat up and about 15 minutes for cool down. So that
That's
is
with no helpers.
that's with nothing, just the plain bed in about a 20-degree room, and just in like open climates, a little bit longer if it's like warmer out.
Yeah.
So like you can put a fan on is one mod that you could do.
You found like the time was basically half by
Yeah, like
that.
just having a fan on the bottom, like just a computer fan, like decrease the time by half. So that's probably like something that we want to work on.
I think an important point to note is that it's not necessarily the cool down time that even presents the issue. The issue often in our experience with printer downtimes and with talking to people who use printers is not having an operator there. So
Oh yeah.
that's where the massive benefit is if you don't have to be at your
Then it doesn't
printer,
even matter.
yeah, it doesn't even matter.
The
Like,
only thing that will improve is the amount of prints that you can get in a certain amount of time, and that's already pretty minimal in like doing that manually compared to with this automated system from 3DQ.
yeah.
Like I've got a kind of a story when I was working in my print lab at my in my engineering program. We do printing for all these different capstone teams, uh, like design teams. So there's like 40 teams all submitting prototypes to this print lab. And we have this day called, or presentation day called Design and Innovation Day, where all the teams kind of present their year-long projects. So, of course, we say get your prints in like 6 weeks before, but people are submitting like the day of, and that basically led us to have to pull an all-nighter, printing as many prints as we could on our six FDM printers. And that's a lot of work, you know, like you gotta stay up all night babysitting your printer. Like if we had this automated system, the amount of time saved would have been amazing. You set your prints at night, set it for like your whole list of prints, whether that's like 100 or 50 or 1,000, and like less payable hours for me, but
Yeah.
oh,
It's okay.
I'll just sit
You'll
there and
manage.
sleep.
You'll
I'll
manage.
buy this for a few bucks and then just sit there and sleep while I'm
Yeah.
getting paid, you know?
So there are a couple questions from chat. Before we get into those, why don't you start installing the part guidance system?
Sure.
It's simply a snap in, so it's super simple.
Let me just grab the cable.
Um, so two questions here. How does the aluminum extrusion handle the vibration? So because the y-axis on the Ender 3 is a heavier axis, it kind of moves in line with the extrusion. So most of like the high momentum or higher momentum moves are actually in line. So it's very sturdy and there's very little vibration in that direction. The x-axis does go cross to the frame, but we've made design considerations to minimize any sort of vibration happening that way. The other thing to note is that if there is vibration between the printer and the frame, it like the frame won't necessarily change. I guess what's key to eliminating ghosting and those types of effects in your printer is vibration discrepancy between the bed and your axes. And so if the whole thing were to vibrate, your bed and your nozzle is vibrating in the same mode, so it wouldn't increase ghosting. If we had the bed mounted to this extended frame, for example, then you could see, then that might cause potential issues. But because the base frame remains unmodified, it all still moves together in the same way it would it would just sitting on like on a flat on its own.
Yeah. I think we have a question about printing one at a time. So I think you have a story
That's
about
actually yeah,
batch printing.
that was actually going to be our next kind of our next section was how printing continuously or with continuous cycling compares to how you might print on a
Print
typical
with like a
printer.
manual, just a manual printer.
So way back before I actually started developing this kit, and one of the big client jobs I had that prompted me to start development on this um, was these breath trainers, which
Mm.
is a device used in physiotherapy where you breathe. Basically, it's a tube you can breathe through, and you can adjust what the resistance to that breathing is, and it's used to help rehabilitate people um, after surgery that might have issues with their diaphragm. And so I started working with this client, and luckily I was in during the design phase, so we had designed it for 3D printing from the ground up. It was two components. One was an hour and a half, and one was an hour 45 or something like that. And so quickly, she was very happy with the product, which is nice. Pat on the back. But then quickly, she wanted like in the end, it ended up being a batch of 50, and then I think a batch of 20 and a batch of 30.
So a heck of a lot of prints.
It ended up being, yeah, it was like around 160 prints total, not counting the failures.
Not counting the failures.
Yeah,
Ooh boy.
with failures, it was probably around 200. But for that job, what traditionally is done is I had laid out a ton of pieces as a batch on a single print bed. And that's typically what's done with 3D printing because you kind of time the prints around your schedule.
Yeah, so you had one of these for like each day of the week, or
it was even more complicated than that. I had 5 batches, three for the weekdays. So I had one before leaving for school, and then it would end just as I got home. And then I would have to start one in the evening, and then I'd start one last one before I went to sleep. And then on the weekend, I had 2 cycles like that that were roughly 12 hours. And so basically, I had to gear the entire production for that took 8 days, and I was like, people like it was a very ambitious, I think, project to try to finish in that time because I literally had to gear my entire schedule during those 8 days around these batch cycles. Because if you slightly go out of phase, you either have to introduce downtime, which gives you leeway in your cycle, so that if you're not at the print right as it finishes, you still have some time, or you have to be really, really punctual, and even then, it's like changes in ambient temp would have caused like the heating cycles to change, and eventually everything would start to shift out of sync. And then the worst thing about doing batches was I had these 5 batches prepared, and we'd have to make a design change, and then I'd have to remake and reslice all of these. And
every single part, or
yeah,
like each batch. So like one little change, it's like the whole.
Yeah, it was super annoying, especially if the update happened within the week, because then I would have made these batches and then not have used them. But I was trying to front load most of the work so that production would go smoothly. One of the other issues with doing batches that we've sort of discovered as we switched to single prints at a time were a batch introduces a lot of retraction and stringing
you can get like stringing and
and it's not which is totally doable. Like we put multiple parts on a plate sometimes, but especially when printing assembled components. But the thing is, it's much less forgiving in terms of slicing. So like if you're doing a single object and you don't have to worry about your retraction that much, it's much easier to slice for that than for a unique batch layout.
Yeah, it's just more work. To produce batch parts. Like it would increase your yield, like over or your efficiency, like per day or per hour, whatever you want. But it's really not necessary when you can have increased quality and better prints.
Yeah, like like if I had this looping kit at the time, I would have just set 48 prints, please, and then just gone and picked it up on my own time. I wouldn't have to worry about constantly like racing back in order to meet the end of that batch. So there's like even though overall it might add some cycle time, it actually like the amount of time it saves for you to do other things, we found vastly outweighs it.
Well, yeah, you can actually go for lunch if you're running a lab instead of waiting. Like you know, say you've got class at school or you gotta leave or you got a meeting. It's like, do you wait the extra 5 minutes for your print to finish so you can start your next one, or do you leave so you can get to wherever you need to be
Yeah,
on
it's
time?
like
It's
how
like,
how
what do you
high
prefer?
how high do you dare turn up that speed multiplier? Like it used to come down to that a lot of the time. So um, and that was really the kick in the pants that really got me thinking like, oh, okay, there's a massive inefficiency here because 3D printing, a lot of it is designed around the assumption that there's an operator that can pick up and deal with the printer at any
Do you
time.
want to throw the LCD screen on there?
Sure, we've just relocated it. Again, it kind of helps with the guiding parts out of the way.
Yeah, just the overall look once you've tilted your printer.
Okay, it looks like Steven's picked up some of the questions too. That's good.
Ghosting, maybe not. So do you get Y layer shifting due to gravity? Uh, no, I don't think so. Like,
Not necessarily. Like on our production machines, there are a couple photos of online.
Yeah.
We actually have the whole printer set up at 90 degrees. And there might be some cases, depending on how fast you're printing. Like we typically do infill at 70 millimeters per second, and then the outer walls at up to 50, sometimes
Yeah.
70. And we haven't really
No,
noticed
like
too much.
that's not really an issue with the printing. Like printing at 90 or 30 or 100 doesn't really impact things. Like the stepper we've tested works fine at the angle.
Yeah.
Um,
Yeah, it's not too big a deal unless you're going like for insane like 100 millimeter per second plus speeds, then ghosting can become an issue. But it tends to be rare that people do that. For like the outside perimeters of a print. If you do, it would be interesting to see what kind of mods you have set up. But one of the other things is when you are building up your Ender kit, it is really important to make sure that everything is tightened down correctly. But that just goes back to the consistency. Like what we've observed is that you might have we might have small faults in how the printer was assembled, and when you're running it manually, issues due to those faults.
So I just turn the printer on there.
Sure. Will tend to be spread out over a long period of time. Whereas when you're running them 24/7, because your productivity is so much higher, you run into those much earlier on. The angle and weight of the printer.
Yeah,
so, sure. All right.
Cool. So firstly, what I'm going to do here is just do a quick leveling of the bed. So, you know, once when you're doing anything major to your printer, you know, we're tilting it a lot, where we've replaced the bed. You want to re-level, and especially if you're going from a different build plate, you'll need to reset your Z offset. And with the inductive probe, that's fairly easy to do through like pronter face or manually. If you have a manual or just a stock printer, you will need to move or relocate your Z end stop switch. But I find it's easiest just to use a pre-made macro through pronter face for the leveling.
Okay. While you're doing that, I'll just go through some of the questions in chat. So MediaDog has a really good point. Whether you want to batch or do single parts really depends on what your availability is. So if you don't want to touch the printer, I would recommend doing single parts because that also minimizes material lost and failures. But if you're around to do a batch, then you can time your cycles to your schedule. Would having direct drive affect the release? No, the release is kind of part of the mainly in the bed, so direct drive wouldn't really affect it. Because the weight is on the x-axis too, the weight isn't it wouldn't it's not going to wear out the stepper motor of the bed. It will put additional wear on your x-axis motors. But that being said, like we have some enders in our production system that have probably seen probably close to like 10,000 hours of
Yeah.
printing.
Well,
In some cases, we did run them continuously for 1,000 hours
that was
just in those 5 days.
and that was 39 printers.
Yeah, that was 9 printers. But like we've run these printers for very long. Most of the failures that we see aren't necessarily due to the steppers. They tend to be more like things falling out of alignment, and those are the considerations we had when designing like this bed mounting system. On our site, there will be we will be setting up a list of recommended upgrades that can increase reliability. Like,
Yeah, so like on all our printers, we've had inductive probes, and the V6 hot ends.
and again, when we're saying like in our testing and in our observations, we have 51 Ender 3 printers that we run and we do both production and testing on. So like we have a lot of data in terms of how this works. The official when we moved our production onto Ender 3s, that was about a year and a half ago now. The kit, the release itself, has been in development for much longer than that. Let me just pick up some more questions here.
I think there's one about the part release.
Yeah. So it's compatible with custom hot ends and custom part cooling.
So yeah, it doesn't take any effort or force to take most prints off.
Yeah.
Especially like if the more you cool it down, the easier the release is, and some prints even fall off or start sliding on their own.
Yeah, just due to gravity. If the direct drive setup is working fine, then it won't be. Okay. Yeah, like we actually considered doing direct drive for some printers, but realized like the Ender 3, we would probably want a bigger printer with that. The other thing, like I said, we will have in our Discord, actually, what we would really like to do as we're sort of wrapping up development of this kit is have some discussions with you guys about what considerations like we might not have contemplated when building this kit. So it'd be really yeah, like it'd be extremely useful to get some feedback and look at some things we may have missed, because as part of developing this kit and this tech, we've actually we've went through pretty much all the common Ender 3 mods, and we'll be providing like in the manual we'll be providing like recommendations for which ones are good. And if you have certain mods like BL Touch, for example, we don't run that in-house, but some of our engineers have BL Touches on their Enders at home, and so we've made sure that the kit is compatible with those as well. And we'll probably throw up over time like recommended kind of setups, so like a recommended BL Touch mount, for example. Probably put up, or definitely will be putting up our inductive probe and E3D V6 hot end mounting system. I saw the. Oh, okay. So in terms of, there's some videos where we use the hot end to bump the printers off. The force left on the print bed is extremely small. So just a small basically shock can cause the entire part to release, and it's very gentle. Like you'll see, I'll see if we have any. We might have some examples online where we do really thin prints, and just because they're so thin and light, they'll just kind of stay in place due to static force, for example. And so we'll use a hot end cage to kind of displace them in a way that causes them to come off. So it's really like it's so gentle that you could just slide it with your finger. We're not doing that. There's a Reddit post a while ago of like a fist that punches your prints off. It's actually very delicate. And that's part of why this surface is so long lived. Like I have the original prototypes I made 4 years ago still function today, and part of that is there are no high forces involved with the removal of parts. So you're not tearing away bits of the surface as you're kicking parts out. It's actually probably one of the most common reasons regular print surfaces like ceramic coated glass or like polycarbonate or PEI tend to wear is that sometimes you have to scrape them or sometimes you have to pull parts off with force and that degrades the surface. Um, with ours, it isn't that big of an issue because the force involved with removing the parts doesn't do it, and then the surface itself is formulated to be extremely durable regardless. So the direct draws, your Ender 3 has the XL mod. How high do you think is it safe to print? So on a vertical surface, we've done prints to the maximum height of the Ender 3. Actually, I wonder if I can grab one of these.
Yeah.
So these are printed on our production system. They're not the full extent. We've done taller parts, but these actually print only adhered by this edge. And it's kind of ridiculous to watch. I think Steven, if you have that video that you sent me, maybe post it in our Discord, but you can kind of print out this way with a tiny footprint. So if your filament is good and consistent, oh, perfect. You can actually print really far out. I don't know if the XL, like, because, so that's 90 degrees. At 30 degrees, you have a lot less leverage on the bottom of the print, but the XL can be massive. This is one of the other prints Steph just brought in that we did that also shows a tall print. This one is much lighter and it has a bigger surface area, but this one is a good example of one where that would be hard to remove from a traditional build surface where you might have like a big contact area. And this just kind of slid off of this kit. So I think it really depends on the part. Again, on a vertical surface, we did do a base that weighed 750 grams. So that kind of shows how high that adhesion can be. Obviously, if you like do something with the surface area of this connected to something like this and it's solid infill, that's not going to work. I don't think any print surface would work with that. So you have to use some level of discretion, like don't do anything super ridiculous, but it's actually quite impressive like what kind of prints you can get off of it, even at 90 degrees.
Yeah. Okay, so this bed is now leveled and the new Z offset is set. So I'll start a print in a minute. But Mateo, how do we get this printer? Like or this kit? Like how do I get one for myself?
Wow, what a good question. How'd you come up with
Can
that
I
one?
just take this one home with me?
We'll see how good you are. Employee of the month will get one of these. Yeah, so the kits are available on our website. We launched them yesterday at noon PST, and we've already sold 24 out of the 30 early bird pre-sale kits. So those ones are $79. There's still 6 left. It's meant to be like a very low cost upgrade, sort of a no-brainer like you would do with a hot end upgrade or an extruder upgrade. So there are, what did I say, 6 of those left. And then because we weren't expecting to run through them so quickly, we're going to do a second round of early bird.
Second round.
Yeah. And so that one will be, let me just double check here. I don't want to throw out the wrong number. I believe it's $86 and that one, oh, $87. And that one also comes with 6 months of the free queuing software. So I guess speaking of the software and seeing as you're about to start the print, just on a high level, so what our software does, it doesn't replace any sort of slicing. It's basically like a host for the printer.
Yeah, so still make your G code out of like say Cura or whatever your preferred slicer is, and we will have some recommended settings in the manual. But it's generally the same as you would slice regularly.
Yeah, so you would import your G codes into the Endless Looping Kit software. And then what you do from that point is you create something called a print job. And a print job is just a G code that has some additional properties that you get when you have an automated printer. So, in our case, a print job might be you have a Benchy G code and you send it off to the printer with the quantity modifier of 100. So if
So
you want to like
you
flex,
really build up your Benchy collection. Be like, oh, look at all these tests I've been doing.
if you want to flex your Benchy collection, you can send a job, and now that becomes a print job, and that's like Benchy times 100, and that will include all like the cycle monitoring and the part removal and all of that stuff. And you can keep doing that with a whole bunch of different models. So you keep sending jobs, and then that list of jobs is what we refer to as the print queue. So there's like there's a screenshot on our website of what the software looks like. The interface is very, very simple. It's simply just a place to store your G code. And what we like to do is upload the production ready G codes into the endless looping software, so that once that code is ready for production, you can just pick from your list, tell the printer how many you want, and send it into the queue. There's a question about USA and paying customs. From what I understand from shipping, if it's under $800 US, you don't have a customs fee. Yeah, so you're just heating the bed.
Yeah, bed's just heating. We're gonna start.
We're gonna see how well you
printing
leveled the
Oh yeah,
probe.
make it or break it.
Yeah.
So one other thing that's going to be included in your kit is this little packet of filament that we mentioned earlier. So this is going to be about 200 grams of the filament that we've been using in-house. So we know it works well, and this is going to provide you with the materials you need to make your first test print. So we've designed this cool little sci-fi looking spool holder, and that comes with 2 bearings in your hardware kit.
Yeah, it's actually a pretty funny story. So this spool holder we'll be using as sort of a tutorial to guide you through creating jobs and sending jobs to the printer. And given that it's a known material, it makes it very easy to troubleshoot kind of what's going wrong in case the assembly didn't go well. So the funny story behind this is we used to print on the stock ones, right? And so what had happened is actually over enough printing time, and hopefully you guys will be reaching like this level of print time on your machines, these holders start to wear down and cause a ton of friction with the spool, which then causes tension in the filament path, which is bad in general. But we had it to the point where the tension was pressing against the extruder hole, and the filament was slowly wearing away through the extruder itself. Like it cut through the brass.
It cut through the brass insert in the hot and slot.
Yeah, it's like a really, really slow kind of scroll saw.
Hey, free shop tool with your 3D printer.
Cut some metal at an extremely slow speed.
Yes. Oh, she's done.
It's a bit high, but I think it might be good. So proper bed calibration, of course, is extremely important. The guide will also go through like how to make sure your bed is leveled correctly. This one looks like it'll go fine though. Good job, Kevin.
Thank you. Glad this isn't my last day.
Yeah.
So far.
This is not your last stream. Not yet. Cool. Okay. So, I guess given that we're coming up to the end, you've got it printed. We put the kit together. Why don't we talk about what's in store for next week?
Yeah.
So we'll be doing these live streams every Wednesday at 5:30. What can we expect to see?
We're going to continue on with different aspects, things like how to improve your automation. We're going to go through the software. Might bring in some special guests from our 3DQ group.
Okay.
And kind of work through some of the things just to improve your experience.
There are some so good question. Can we see the software? So next week is going to be all about doing basically walking through creating jobs, preparing prints um, for production, and then submitting the actual jobs through our software. So we'll actually do a deep dive in that. In the meantime, we do have some videos up online of our production software, which we use to manage our printer network, and there is also I think a couple screenshots up on our site right now. But because we are kind of moving our production software and repackaging it into something that's more like
User hobbyist friendly,
yeah. Like the thing with having internal software is that it doesn't always have to be very pretty.
Yeah.
So we're still in the process of just cleaning it up and making it look nice. And so next week we'll go through and present something that you can expect to receive. Yeah, like basically what it'll look like when you get it in January.
Yeah, no, if you want to see this printer or like what's in the kit running a little more active, we do have a live stream, which you can see kind of in the bottom corner. And that's just a continuous stream of prints running on off one of the kits. I think it's been running for about 18 hours now. We've done some headbands, a few cable clips. So you can see our print removal system there. The parts do kind of just slide off. Sometimes they get pushed to the side, but that's why we have the part guidance plates.
So in terms of the kit shipments, we're planning to hit January for those. But what we're kind of preparing to do is send out a whole bunch of early kits to reviewers, like prominent community members or just people who would like to review and do feedback. So if you're interested in getting a review kit in around November, please contact us through a forum. Tell us who you are and why you want to review one of these kits.
Write the essay of your lifetime.
Yeah.
You know.
Kevin will scrutinize them very closely.
Oh, only this many followers? Wow.
Okay. I'm not gonna do that, but yeah. So like, please let us know. We've already got a couple kits reserved going out to reviewers, and we basically like to get as much feedback as possible before we ship out in January. Part of the decision to do a pre-order that's a couple months long is again collecting that community feedback so that we have a number of users that have given their input by the time the
yeah. If you do want to ask us more questions, we do have a community Discord. I think the link should be in the Twitch or on the website. So you can ask us more detailed questions there, and we'll be doing another live feed next week. In terms of this question, is the software farm compatible? So
we'll have more news on that later.
Yeah, we'll have more news. Like we do have a production setup with 36 printers, so it does work in some form, but we'll have more information on how that can work with you.
If you want to talk more about that, just please contact us directly. But we'll have more news on that coming quite soon, I think. So yeah, just to recap, there's only a couple of the early bird kits left at the reduced price of $79.
That's about half of what we'll probably sell for normally.
Price. Yeah, and then we'll be doing another run of 50 kits at the $87. And both of those come with 6 months of free software. After that, the pre-order will end in 3 weeks. And for the rest of the pre-order, the price will be $97 with 3 months of free software. All these kits are set to ship out in January. Yeah. Well, we're 1 minute under time.
1 minute under. Wow. So it took less than an hour and lots of babbling on our part.
Yeah.
So we do have some experience putting this together already, but it's not terribly difficult.
Yeah.
So it's definitely something you can do at home. All it took were 2 Allen keys, which I think come with your ender already.
So last but not least, one more ask from you guys. If you have any sort of challenging parts that you've printed and want to see how they print on our machines, please send them to us. We'll be doing a bit of a challenge and kind of the part that we find the hardest to get working will like win a couple. I think it was a year of free software.
Yeah. Still working it out, but we'll throw it on the live feed maybe.
Yeah, it'll go on that kit once we get it set up. We'll put it up on that.
Yeah, of
kit.
course it has to be something that's theoretically possible. You know, we
Yeah.
don't want just some floating
Yeah,
part.
like, no.
Oh, it's just spaghetti.
Yeah, like 4-dimensional, non-Euclidean shapes. Like it has to be of this world, and it has to be something reasonably printable. But it would be really cool to get like some parts that you personally struggled with, and then see how they compare. Whether we can get them going on the automated kit. Yeah, I think
that sums everything up.
Closes it out.
Yeah, so thank you for joining us. Join us again next weekend, Wednesday, 5:30. We're going to be doing this regularly. If you have any questions, again, join our Discord, our community Discord. We have pretty much our entire team. We are a bit of a startup, so we try and reply quickly and in detail. So, yeah, thank you for joining, and hope to see you next time.
All right, bye, cappuccino. All right, see you next week.